Welcome back to The Explainer. Today, we're diving straight into a genuinely fascinating paper from May 2026 called AutoResearch AI. Now, if you've been following the tech world even a little bit, you know AI is literally everywhere right now. But this paper, it pinpoints a massive foundational shift in how scientific discovery itself is actually conducted. We're looking at a future, and honestly, in a lot of ways a present, where AI isn't just some passive tool we use to crunch numbers, it's becoming an active participant in the research process. I mean, just imagine an AI autonomously running its own digital lab overnight while human scientists are fast asleep, and then churning out a completely novel discovery by morning. That is exactly the threshold we're standing on today.
So it really begs the question, doesn't it? Is AI ready to be our new lead scientist? Because up until now, we've largely treated AI as this highly capable, super fast assistant. It drafts our emails, it debugs our code, maybe summarizes a dense PDF for us, but the grand premise of the research we're unpacking today challenges that perception entirely. This is a radical departure from just chatting back and forth with a large language model. What actually happens when the AI stops just taking notes and starts proposing the hypotheses, running the complex experiments, and then writing the final peer-reviewed paper?
To wrap our heads around this, here's our roadmap for today. We'll start with the AI science shift, then define the new era of vibe research versus auto-research, map out the 5 steps to discovery, look at the rubric for grading the AI scientist, and finally, do a reality check with the limits of machine science.
All right, let's jump right into part 1, the AI science shift, moving beyond the assistant.
The authors of this paper hit on a really crucial distinction here. They highlight that we are transitioning from task-level AI for science to workflow-level research automation. Basically, we are moving past isolated, one-off assistants. A task-level AI is when you ask ChatGPT to, say, fix a broken line of Python code or translate a paragraph. It's a one-and-done interaction, right? But workflow-level research automation means handing over long-horizon operations. We're talking about giving an AI system a broad, ambitious goal, like find me a new protein structure, and letting it autonomously coordinate research, run its own simulations, compile the data, and even adjust its own parameters over 2 full weeks to reach a conclusion, completely without human intervention.
Which brings us to Section 2, Vibe Research versus Auto-Research. We're really defining the new era of science here.
The researchers actually use a great umbrella term to capture this entire massive transition: AutoResearch. They define it as the developmental spectrum of AI-powered scientific workflow automation. And I really want to emphasize that word, spectrum. It is absolutely vital here because it acknowledges that this isn't just the flip of a switch. We aren't jumping from human scientists today straight to robot Nobel laureates tomorrow. It's a sliding scale of automation. And understanding exactly where a specific project falls on that spectrum is crucial to figuring out how much we can trust it. To categorize where we mostly are right now on that spectrum, the authors coined a term I absolutely love: vibe research. This is what most of us do today. Vibe research is deeply human-steered. It's prompt-based assistance where humans verify every single execution. You definitely know the feeling. You're just endlessly bouncing half-baked ideas off a chatbot, you vibe with it, but you are very much in the driver's seat steering the ship. Now contrast that with the emerging AI-led systems. These systems coordinate much larger portions of the discovery loop autonomously. It's a far more clinical, self-directed process where they don't need a human to prompt every microstep. Though it's worth noting, the paper is very careful to point out that these AI-led systems haven't quite achieved robust, complete autonomy just yet.
So, how are they trying to get there? Let's look at Section 3, the 5 steps to discovery, or the AI scientist's workflow. The authors organize this entire field into 5 key steps. To really see how this works, let's just narrate the journey of a single hypothetical idea moving through this loop. Step 1. Literature and research grounding. The AI autonomously ingests, say, 10,000 papers on material science to understand battery technology. Step 2. Hypothesis formation and planning. Based on all that reading, it proposes a brand new chemical composition for a more efficient battery. Step 3. Experimentation and tool use. It actually writes the code and runs a complex digital simulation to test that formula. Step 4. Feedback, validation, and review. It analyzes the simulation results, realizes the battery would probably overheat, and adjusts the formula on the fly. And finally, Step 5. Reporting and knowledge communication. It drafts a full manuscript detailing this new battery structure. This is the exact loop human scientists traverse, and AI systems are now being engineered to do the exact same thing from start to finish.
But look, despite these incredibly impressive steps, current systems still struggle to act like real scientists. For instance, there's fragmented autonomy, meaning the AI might crush steps 1 and 2, but completely break down at step 3. Or my personal favorite from the paper, weak direction rejection. This is a fascinating insight. It basically means the AI often doesn't realize when an idea is a total dead end. So instead of just giving up and pivoting like a human would, it just keeps digging a deeper hole. Then, of course, you have massive issues with provenance tracking and reproducibility. And these have serious real-world consequences. Think about it. If an AI invents a life-saving drug but cannot explicitly explain its chemical reasoning or show you exactly where it got the evidence, the FDA is never going to approve it. Without a rigorous, traceable paper trail, it is simply not useful science.
And because of those hurdles, we need Section 4, Grading the AI Scientist, a new evaluation rubric.
How do we actually measure success here? The authors propose 5 critical evaluation dimensions for automated systems: novelty, validity, impact, reliability, and provenance. Let's just flesh out the first 2 for a second. Novelty and validity are literally the difference between an AI merely hallucinating a plausible-sounding paper and actually doing rigorous, new science. An AI can easily string together academic jargon that sounds incredibly impactful. But this rubric forces us to stop and ask, is the underlying math fundamentally valid? And is this discovery actually novel to the world? By applying these 5 dimensions, we transition from just being amazed that an AI can write a paper to rigorously verifying if that paper actually contributes trustworthy science.
Finally, we arrive at Section 5, the limits of machine science. Time for a quick reality check. A massive takeaway from this study is that AutoResearch is deeply domain-conditioned. In plain English, where the AI is working completely dictates how well it works. AI absolutely thrives in structured, executable, and rapidly verifiable settings. Think pure mathematics or software engineering. In those environments, an AI is a total powerhouse. It can write a piece of code, run it, see if it compiles, and verify the result in milliseconds. But contrast that with where it struggles: embodied, delayed, or ethical contexts. An AI cannot easily run a physical biology wet lab. It literally does not have physical hands to pipette liquids into a test tube. It can't easily navigate the delayed, multi-year results of a clinical trial on heart medication. And it absolutely struggles when navigating complex ethical review boards because an AI doesn't inherently understand the moral weight of testing on human subjects, right? The environment dictates the autonomy.
And all of these limitations point to a deeply provocative question regarding accountable scientific closure. Think about this. If an AI autonomously runs the loop, generates a brilliant hypothesis, and makes an actual breakthrough, but lacks the institutional accountability to stand behind it, who truly owns that discovery? Is it the human who initially typed the prompt, the developers who train the AI model, or no one at all? As we shift away from casual vibe research toward fully autonomous auto research, this is the reality we have to figure out. Thank you so much for joining me on this explainer, and definitely keep questioning the science behind the screens.